So, brief pause. So, Steve, can you give us a brief introduction to the technology that was used in the houses from your perspective?
Okay, thanks, Mark. Yes, so just to take things back a level and start from the beginning, really. I've been working with a business called Dynamis Associates, and they have provided me with data on 19 different types of properties across the northwest of England, and each of these properties has been fitted with an air source heat pump. I'm not actually party to the type of heat pump that was installed within that property, whether it's, for example, a Hitachi or some other make or manufacturer. So I'm not actually aware of the specific type of kit or the typical manufacturer of heat pump that was installed in each property. All I have is the real world minute by minute energy use of that heat pump. Does that help, Mark?
It does. That was the pause.
Okay.
Right. Another pause, then questions.
Okay.
So, Steve, in speaking to Dynamis, I believe that they install both solar panels and battery storage. Are you aware whether they had any of those systems installed in any of the houses where you sort of monitor the data, or as far as you're aware, is it only heat pumps?
Yes. Okay. So of the 19 properties that I analysed over the past 12 months, not one single property was fitted with a solar and battery combination. They were purely air source heat pumps fitted to an existing property, 17 of which, by the way, were solid brick with no insulation. So they were purely retrofits of air source heat pumps onto existing properties with nothing additional, no other renewable technologies fitted.
Thank you, Steve. Any questions from Roland?
I don't think so right now. I mean, I'd like to learn more about the findings, but I think we're coming on to those.
Okay. So another pause. Steve, could you tell us some more about the details of the study that you led with your students?
Absolutely. So I will, probably the easiest way to do this is if I share my screen. Hopefully this will work fine. Now you should see a spreadsheet that appears on that screen, and the best way to talk you through this is to look at this spreadsheet. If we start on the top left, I was provided with the address of the property. You can see here on row 1, the house type, whether it was detached, semi, and so on, the number of bedrooms, and the wall type. So you can see that here on the top left. I was also given a EPC, so anyone can do a search online at the EPC. There's the reference number, and the date of the EPC assessment you can see clearly here, and the date of the air source heat pump installation you can see here. Now the EPC informed us that the energy required to heat that property was just over 25,000 kilowatt hours. What I then took from the EPC was the estimated costs for electricity from lighting, and then gas from heating and gas from hot water. Again, just taken from that EPC, which is available online, and that's over a three-year period. So I just divided this number by this number to give me an annual estimate of cost. In order to operate that property for 1 year, as an average, it's just short of £2,000 on the heating bills. Then what I did was to look at the data from a heat pump. And when I say data from a heat pump, obviously the heat pump was fitted in March, so we had some data for that month, which you can see here. So this is a separate platform. Each heat pump fitted, you can actually take the real world performance on energy used by the heat pump. So I had a start and end point for each month, and then this was the overall amount here. Let me just go back. So these were the actual kilowatt hours of energy used by month. These were estimates for January and February. So I just estimated here for January and February based on this trend. So I think that's a reasonable estimate to make. So just to finish really on this, the homeowners, if they had a standard tariff of 16 pence per kilowatt hour average, then by putting a heat pump in, they saved around £750 for that year. And then it took things a step further and said, well, if they were able to maybe look at Octopus and different tariff structures as what is called a heat as a service model, and if they could get that price down to about half, which is achievable, then the savings are even greater. So that, before I talk any further about the wireless study, that's in sort of detail how I went about collating data for each individual house.
Thank you. Do carry on.
Okay. So what the next step would be, this is the EPC. So this is the pounds per year as an average. You can see there just £1,800. And then by fitting a heat pump on this one property, based on this real world data, this is what the cost reduced by. And then I've estimated, well, what if we have this heat as a service? Then could it be further? Yes, is the answer. And what if we added then solar? And what if we added solar and battery to that property? Then what would we expect it to see? Now, I don't know the answer because solar was not fitted and battery is not fitted. But that's this could be a good route for that particular home to have no energy bills whatsoever.
That makes sense. Thank you.
Okay.
Do you want to talk about the wider study a little bit more?
Yeah, absolutely. So what I'll do, I'll come off this screen and I'll move on to another screen now. So now that we've learned about the way in which I undertook the study for each home, and you can see that particular house that we looked at previously was Denton Drive, which was this property here. So let's just very briefly talk through that again. Address, type, number of bedrooms. Actually, I think it's a 4-bedroom house. My mistake. So it's not. That should be 4. Wall type, annual cost. Air source heat pump was in for 10 months, but we estimated for 12. And then the different pricing structures and savings along here. But what I've also done is to look at a CO2 saving as well. So the CO2 saving was, just over 3,500 kilograms, so 3.6 ton of carbon. Well, 3.7 to sort of round up. So we did this with students. I gave a group of 60 master's students at the University of Liverpool. I put the students into groups of 2 or 3 or 4, and then each group of students had a certain property to inspect. So they inspected the properties individually, and they essentially carried out the same analysis I've just shown you on the spreadsheet. So I gave them the data, the platform, the information, the EPC, and they gave me back a spreadsheet. So I had 65 in total, 65 spreadsheets, all of which, were these sorts of houses here. So this would be for Rutland Avenue, for example. I think 4 students analysed that, and this is what they found. So that was a bad example to pick because there's a few errors on that one. But for the rest of the properties, you can see here, they analysed it, and these were the results that came back from the study. Now, some houses, fitting air source heat pumps From this study, this very small sample size of 19 homes, there were 2 properties, which you can see here and here, which actually cost more money to run than without the heat pump. Now, I've looked into this, and there's quite a funny story around this one. So this Dynamis associate to the MD, this is his nan's house. Okay, so his nan, who was very cold in the winter and all the rest of it, she had a air source heat pump fitted, and because she's quite elderly, she didn't understand how an air source heat pump works. And what she was doing is she was getting up in the morning, switching on what she thought was a boiler, and when she goes to bed, she'd switch it off and on again and off again and on again. And this is really significant because that heat pump now is actually costing him more money, you know, to heat the home, and that's because she's not using it properly. And the same here, I'm not sure on the exact details for this one, but this is costing the homeowner more money. So it's really important that we can have the best solutions possible, but if the homeowners aren't using them properly and aren't educated in terms of how heat pumps work, then you're going to end up spending more money. So the vast majority of these case studies here, you know, different savings. This is only £8. This is £1,200. You know, every one is different, and it depends upon the use of the system and how educated people are to use the heat pumps. So that's all on a standard tariff, you can see here. But if everyone switched, of these homeowners switched to an octopus tariff, so the old economy 10 type tariffs, and I'm able to, you know, buy energy overnight when it's cheap and use it every day, things like that, then the savings are even greater, as you can see here. So the average saving would be about £900. Average saving on standard tariff, just short of £500. And then the CO2 saving here as well. So that, in essence, is the study with the university, and you know, that it doesn't really stop here, because these heat pumps are still working since they were installed. We've got another 12 months of data, which we'll have next summer. So then we'll have sort of 2 years of data on this, and we're going to keep tracking and monitoring how we get on. What we're also hoping to do when the students get back after the summer break is to go and actually interview each of these homeowners and say, right, now that you've had a heat pump fitted for, you know, 12 months, 18 months or 2 years, how is it responding? How are you doing? Is it providing the same level of heat and comfort? You know, where are we with that? So that'll be a really interesting post-occupancy evaluation too.
That was the pause. Thank you. Roland, any questions?
Steve, that was really interesting. Thank you. One question I have is about the generalizability of the findings. And in the written report, one of the written reports that you've shared with us, you're very careful to talk about the limits to generalizability. And I'm really interested in this because we're often talking with people who are thinking about a range of different properties, and the study that you've conducted applies predominantly to semi-detached brick buildings with no wall insulation, if I understand correctly.
Correct.
I'd be really interested to know what you think about what this means in the context of other buildings, other domestic properties in particular, and yeah, and if there's anything that can be generalized here for
I think. Yeah, absolutely, Roland. You know, fantastic question. I would not like to generalize anything. If I'm being honest, open, and frank with this, the sample size is too small. We need to do this on 1,000 properties across different types of products. I am really, what's the word to use? I was about to say surprised, because a lot of the literature out there mentions that air source heat pumps do not work unless you have almost a passive house design, which is fully insulated, you know, which minimizes heat transfer and heat flow and so on. And this result, or this study, seems to go against that, really, because we've got, 17 houses here with no insulation, with solid brick, yet we're still able to achieve savings. Now, why is that? Can we generalize that and say, well, okay, well, this will happen across 1,000 properties? I don't know. I really don't know, and I'm not going to generalize in that way and say that this will be a solution for every single 4, 5, 6 bed solid brick non-insulated property out there. Will this be a typical trend? I think it could be. In fairness, I did say I'm not going to generalize, but I am slightly, 19 houses, every one of them bar, 1 or 2 is showing a positive result. What I want to do is go back to the homeowners and interview them and say, how are you using the system? How is it automated? Are you involved? Are you not involved? So I think there's a lot more work to be done yet before we can generalize and make any conclusive remarks on this. Just to add another quick comment as well, these are probably some of the most difficult houses out there to install heat pumps on. They're not well insulated, really. Solid brick and so on. I would expect if this study was commissioned with new build, with houses with meeting current building regulations and a much more airtight and a better fabric first approach, I think the results will be hugely better than what we see here. So I think this is like worst case scenario, still with a positive spin.
And can I add to that? I'm inclined to agree that the results are sufficiently strongly positive across most of the properties that, thinking of a diocese that nominally owns the presbyteries, and so even if in 2 or 3 presbyteries a heat pump costs slightly more to run, for the diocese as a whole, hopefully there would be an overall cost benefit as well as the carbon benefit. And as I'm inclined to agree that you've picked some sort of fairly sort of difficult to treat homes. We'll be getting some further sort of opinions on that to sort of. But the video allows us to sort of make the details of your study more transparently available to others that have expertise in this area than we've been able to so far. Brilliant.
Absolutely, Mark, and we can pick a lot of holes in this small study. Of course we can. We could say, for example, well, how robust is the EPC that was carried out? Are you comparing real world energy use from the heat pump, but we're not really comparing real world energy use because it's based on a EPC. There's things like that, but I think all of these things average out. So the bigger the case sample size, the better that averaging will be. So I would love to do this on 1,000 properties, and then come back and say, right, we've got some conclusive evidence now on this. If you ask me now what I think, I still think it's positive. I still think it's a fantastic option, fantastic solution. Carbon reduction, cost saving, both there, both evident, even in that small sample size.
Great. And just as a sort of an aside, John Kent, that you met one of the meetings that Roland organised, he's doing something similar on some new build social housing. Similar sort of sample size, so a different methodology, different people, different company, and hopefully will give a similarly positive response. Any further questions, Roland?
Yes, I think one quick one, and one very quick sort of reflection and almost kind of note of encouragement in a way. I think that because although the N is small and it's not statistically generalizable numbers necessarily, it is an extreme case sampling strategy. So by choosing some of the worst or hardest buildings to heat in a cost-effective way, by showing that it can be done in buildings that are traditionally perceived to be very difficult, then that does bode very well for everything that's perceived to be more straightforward. So there is some degree of kind of maybe not generalizability as such, but transferable understanding perhaps. And then the other thing that that I wanted to ask is, how does this plug into the existing findings, the existing understanding on the economics of heat pumps? Is this a controversial finding, or is this a relatively unsurprising finding?
I think it's quite a controversial finding, Roland. I think a lot of the information out there has been in opposition of this, really. But the sort of counter argument to that is that, in a way, the way in which I've undertaken this small study can't be argued with, because it's taking data from a air source heat pump through a sensor and a monitor, which again, the monitor did not come from the manufacturer. It's just an independent platform. So the data that I get is every minute of every day. So we could go onto the platform and you can see real time how much energy that heat pump is consuming. And then when you work through what's called the coefficients of performance, how many units of energy that heat pump needs to provide the right heating for the home, the information can't lie, really. That's how much energy it's sort of using, really. So it does go against standard thinking. However, standard thinking isn't, there's not enough sample, there's not enough case studies out there. That's the problem. I'm very, very fortunate to have 12 months on average of data for these types of houses, but other companies, other bits of research, companies will fit an air source heat pump in, but they won't monitor. They'll just fit the heat pump and move on to the next. At least with this, we've got some form of sort of POE, post occupancy evaluation. So it's difficult, Roland. It's hard to compare like with like. It's tricky.
And can I add to that? So I've just had a quick look. There isn't a huge amount of academic literature, as far as I can tell, in the UK, that's done a comparable study. So we're comparing a proto-academic study with sort of word of mouth, effectively. So the videos on YouTube that say that it's a bad thing, and badly stored air source heat pumps, etc., poorly advised customers that have installed heat pumps, may well be losing money, but you've given an example of how that might work, and absolutely there may be some properties where it may cost more to run, and something that would be helpful, which I don't think is available. It would be a better way of being able to say before a heat pump is installed, for the occupier to know whether it's going to cost them more or less. I mean, I think the carbon savings are fairly clear cut. It's potentially the cost implications that are sort of less clear.
Absolutely. Can't agree more, Mark. And I think it's that's down to the government's renewable heat incentive, which is still live and active. Funding still available with this until the end of March 2022. So from a cost perspective as well, it's the cost of installation, which is the highest cost, of course, that can be, in a lot of cases, can be met by the renewable heat incentives. So this can be, for a lot of people, a zero cost solution to them. There may be a small contribution to pay, depending on the size of the property. The renewable, it's worth just mention that for a second. The renewable heat incentive, which is operated by the UK government, if the energy, the higher the energy use within a property, the higher the renewable heat incentive is. So that could be part of this as well, because these properties that I've assessed, some of them are 6 bedroomed, semi-detached, 5 bedrooms. The average is 4. So they're quite big, substantial properties with quite large energy requirements. So maybe that, I mean, it'd be interesting to look at smaller 1, 2 bed properties and see if the savings are comparable. But there's not much out there to sort of do that, really.
Just to sort of add to that, so just to sort of clarify, the renewable heat incentive is paid over 7 years on the basis of the amount of heat used by the property. So as you say, smaller properties would use less energy and use less heat. So the incentive would be less beneficial to them.
Absolutely, absolutely, Mark. Yeah.
So for larger properties, even if in the medium to long term, the running cost might be higher, if there's enough sort of benefit in the short term from the renewable heat incentive, that might not only sort of pay back the initial installation costs, that might deliver financial benefits which can be sort of offset potentially against the cost of the electricity, presumably until the cost of gas increases enough that but yeah, it may well be that smaller properties will sort of benefit less than larger properties.
And also to add, Mark, we haven't mentioned this so far, but the reason why this is cost effective, in my opinion, to do now is because of what's called the assignment of rights. So companies can install the heat pump as long as you assign your rights to them. So they effectively get paid for the next 7 years from the renewable heat incentive, which means that for the homeowner as an individual, the cost to them are sort of minimal. So that assignment of rights has a large role to play in this as well.
For which people would need to be considered carefully. Yes.
Yeah. So for the homeowner, they're probably thinking, well, why is a company fitting an air source heat pump to my property for free? Nothing in life is for free. Well, the company gets paid through the assignment of rights. So as long as you're happy as a homeowner to assign your renewable heat incentive to that business, then that's how they can fund their operations. So it's a great solution for both the homeowner and the business.
Okay, that was another pause. Any further questions or anything else that anybody wants to say?
No, there's nothing from me, Mark, unless you wanted me to go into a bit more detail on a certain aspect or anything. I mean, I think the results, as I mentioned earlier, really the results just speak for themselves on this, and I really would like to get further down the line, and another 12 months of data and things I can then reflect and say, well, actually they're a bit higher or a bit lower than what we think, but until that time, it's tricky.
Thank you. I'll stop the recording now.